Perfect. Welcome to AAPEX 21. My name is Richard. I am an Autel trainer, and we're going to be talking about ADAS. But I want to start my presentation, my demonstration, with a story, okay? This is the story of a distracted driver. A driver that is holding his cell phone while driving because his kid just got out of school, right? Or he has an emergency or whatever. And all of a sudden, he hears this beeping sound, and when he raises his eyes, he sees that car right in front of him, right? ADAS, Advanced Driver Assisted Systems. That's what this stands for, right? These are the systems that have two purposes. Increase the safety of drivers and decrease the severity or the number of accidents, okay? So, we're talking about the potential decrease of millions of accidents just with forward collision warning or automatic emergency braking systems. The implementation of these systems are already ongoing. And we're going to see that in 23, practically 90% or over 90% is going to have these systems. So, let me ask you all a question, right? How can you tell that a vehicle has ADAS? How about you?
I just look for cameras in front of the car.
Yeah. Yes. Right? All these systems are going to have components. And the components that we see, I would do a visual inspection, right? Any diagnostic process or procedure starts with visual inspection. So, I'm going to look for cutouts in the windshield. I'm going to look for radars on the grills. I'm going to see on the side rear view mirrors if I'm going to have any lights for blind spots. And then I can move inside of the vehicle to check if I have any dash lights, like a pre-collision light, or I have any buttons on the console, or maybe even the steering wheel, right? So I'm going to check to see if the vehicle is equipped with ADAS, and then I'm going to calibrate. So Autel utilizes two types of frames for ADAS calibration, okay? And when we talk about ADAS calibration, we have the standard crane or the portable crane. You are either doing it in shop or you're going to other people's shops and doing it there. Right? So the advantage that you see here, we're going to be talking about the intelligent ADAS optical positioning system. Okay? So with ADAS, the critical things are positioning the targets, okay? And when we're calibrating, we calibrate the component, not the system, okay? So, I have a camera. And this camera is a forward-facing camera. But this camera acts like an input of images. There's software developed specifically for lane departure. There's a different software for auto high beam. There's a different software with pre-collision. All of them utilizing the camera as an input. That's why when I calibrate the component, not the system. So every calibration, because we are dealing with safety systems, starts with a pre-scan. And so that's what we're going to do first. if we can make sure that we have the key on, we're gonna connect our VCI. So you're gonna see on the screen, on the lower bar, there's a VCMI. That's basically telling us that the interface is connected to this tablet. I'm going to enter the diagnostic function, and I'm going to go to auto detect. Okay. So the first thing I want to do is enter a repair order number. Why? Because I'm going to want to track my record. This is for my record. This is for me after the fact, in a couple of weeks, if I need to pull anything up, I have the record. So whatever RO number you're going to use, you can use that for your pre-scanning function. Okay. So once I have ID'd the vehicle, I'm going to go into my topology or my list of controllers. This is very important piece here on topology. Why? Because if you're a shop, you like to see a graphical representation of all the components, all the computers, and the wiring. Or I can just scan. Now, when doing my fault scan, I'm going to enter the information for my insurance purposes. And I'm going to start that pre-scan process. Okay. Why is pre-scan important on an ADAS calibration? Absolutely. That's the correct answer, documentation, because they're dealing with safety information systems. There's also another purpose that we use the pre-scan, and that is to assess the condition of the component we're going to calibrate. If that component has a fault, and the fault is an active fault, we need to troubleshoot that fault first before we can proceed with the calibration. Now you want to know what's going on with the vehicle. So apart from documentation, we also want to assess the condition of the vehicle to answer the question, can I proceed with the calibration? So here we can see it's asking, do you want to attach photos? Very important, especially when we are dealing with vehicles and end users saying, hey, that scratch wasn't there when I brought the car in, right? So we can add up to 5 pictures on my pre-scan. Typically, we recommend whatever component, taking a picture of whatever component you're going to calibrate. And then you can add up to 5 images on pre-scan and 5 on post-scan. So here we can see that we have faults, existing faults, right? Note that with the ADAS, with the Autel system, it actually highlights with that blue box what systems are ADAS. So I can go in and say, okay, here I have my lane camera system. And this is the system that I'm going to be calibrating. I have no faults in this system. Okay? Now I'm going to exit the pre-scan mode and re-enter the record to actually go into the ADAS calibration process. Now, one of the things that you'll notice is that with Autel, it's very easy to get to that calibration process. So not only do you have the most comprehensive coverage of any ADAS system out in the market, you also have a step-by-step process that you can follow. And when following this step-by-step process, you're going to be able to calibrate these components. So notice here, right? I talked to you and I told you, hey, there's different softwares and components. When we calibrate the component or the software, what do we calibrate? Component or software? Anybody? Component. Yes. Right? So here I have my laser radar. I have intelligent cruise control. Okay, I have intelligent cruise control, advanced driver system. Okay, so we have these systems here, but only one has the actual component tied into it. Okay, so I'm going to go to the lane camera because I'm going to calibrate the camera first. All right, this is for documentation purposes and will appear in the report. It's going to ask me, what's the reason that I'm calibrating? Most of the time, it's because people replace the windshield, right? So when do I calibrate? When do you guys think one needs to calibrate? Wheel alignment, yes, if I'm varying the thrust angle on the vehicle, it's going to impact the direction of travel, so absolutely. What other scenario would I need to calibrate? So, anything. Yes, if you're going to remove the grill, absolutely, right? So anytime you are taking the component out, putting it back into place, you're going to calibrate. Why? Because we are modifying the actual position of that sensor, right? Pitch, yaw, and roll of that sensor, okay? So those are definitely, absolutely instances and scenarios where you're going to calibrate. Other instance, raising the vehicle ride height, right? That's another instance where we would calibrate. So, now that I have selected the reason why I'm calibrating, now I'm going to select the type of target and if I'm actually utilizing an alignment rack or if I'm doing the calibration on a level 4. So in this case, I am doing it on the level 4. Notice here that it's actually going to tell me all the targets and part numbers that I'm going to need. So this is a list of tools that I want to make sure that I have so that I can do my calibrations. It's also going to tell me about the other conditions that I need to meet in order for me to do a calibration. So I have to set up my environment. Okay? When I'm calibrating, I need to make sure the lighting, especially when it's camera-based, lighting is a very important factor on camera-based calibrations. The other thing I need to make sure, I've got enough space in the background. Right? I don't want to have any white and black patterned objects behind the camera and the target, okay? Because otherwise, we don't know what the camera is calibrating to. So here it's going to give us a detailed list of instructions. Make sure the vehicle is parked on a level surface, center the steering wheel, keep the front wheels of the vehicle in straight ahead position. If necessary, perform wheel alignment first. Now note, this system, the IA800, is capable of doing a alignment pre-check. So when you buy the IA800 system, you can add the targets. It's going to come with 4 targets for the wheels. It's going to come with the cameras, which is 6 high-resolution cameras, which give you an accuracy of 1/100th of a degree. Okay? So it's a very accurate placement, frame placement. Now, it's also telling me there should be 5 meters in front of the vehicle. Make sure the vehicle view is unobstructed. Now, I'm going to tell you, in the state of Texas, we have the bird, the national bird is the mosquito. And I've had instances where there's bugs crawling inside the windshield, okay, inside the camera mount. And I have had obstructions, or I have people that simply were not very careful when they removed the camera. They placed their finger on the lens. And so now they have a big fingerprint on the lens. So we just want to make sure that we have nothing obstructing the view of the camera. Next, we talked about environment, right? Lighting, background. But there's another component very important that we need to set, and that is the position of the vehicle. When we are doing our preconditioning, we're going to make sure the vehicle is at a specific standard. Pitch of the vehicle, yaw, and roll of that vehicle. Okay? So my scan tool is going to give me the instructions on how to set that vehicle up in order for it to be a known pitch, a known yaw, and a known roll. Ensure the coolant, engine oil, gas tank is full. What is that going to affect? Pitch, right? Adjust the tire pressure to the specified value. What is that going to affect if I have a flat tire? It could affect the roll and the yaw of the vehicle. Okay? Ensure the camera and windshield are clean, and then all doors are closed. Apply the parking brake. Right? Very important instruction. So we need to follow step by step these instructions. It's going to tell us here a very important note. Okay. All right, here it says tap to set up, to view setup steps or a video. After completing the setup of the calibration frame, then we're going to tap OK. So the first portion is the setup. So we're going to go into the frame placement, which is the very, very important piece. Now, when I'm talking about frame placement, I'm talking about this crossbar here, okay? And I'm going to talk about the position that this crossbar is in respect to the component that I'm calibrating. So there's three things I'm going to do. I'm going to set a distance, I'm going to center this crossbar, and I'm going to square it to the vehicle. So I'm going to hit the setup, and it's going to allow us to see the setup instructions. Okay. But here it's going to give us the ability to actually go through on the frame. First thing it has me do is it has me recenter all my different adjustments here. This frame has adjustments for cross, lateral adjustments or yaw adjustments, and then it has also a squaring adjustment. Okay, so I'm going to make sure that all these are zeroed out. That's the first step. The next step is going to ask me to actually center the frame or the crossbar to the vehicle. And it says, keep the front wheels of the vehicle in a straight ahead position. Place the calibration frame directly in front of the vehicle. Adjust the height of the crossbar to ensure it is roughly at the same height as the center of the front wheel. Why? Because our cameras need to see those targets. Okay? So we need to make sure that our height is roughly the height of the crossbar. Okay. Notice also, this is one of the nice things about this frame is that it has a powered motor. Hold the handle calibration frame and slowly move the frame until the horizontal distances between the centers of both front wheels and the back crossbar is basically equal. So, plug the included cord output and turn on the power switch of the camera group. So we're turning on the cameras at that point, right, which the cameras are already on. Next, it's going to ask me to place these targets on the rear wheels. So I'm going to place, and these targets are specific to each wheel. So right rear, left rear, right? And then we're going to have our distance target. This is our distance target. And we're going to place it on the front center axle. Okay. You got it? Perfect. Alright, place the distance measuring target near the center of the front right wheel of the vehicle, subject to driver direction. Okay. And make sure that that pointer is pointing to the wheel hub. Okay. Let's hit the next page. Take you a little bit to update. While we are updating that, it's initializing the cameras, and now it's going to see the targets on the rear wheels and my distance target, and it's acquiring the position of the frame relative to these targets. So I'm going to hit OK here. And we're going to remove this distance measuring target. So you notice here I've got live readings, and it's telling me how I need to position the frame. So this is the spec. I have to set up, again, distance, center, square. So here it's telling me that I am at 3,139 millimeters, which I need to bring closer so that I can get a reading of 3,008. That's the actual statement. Next, it's going to tell us to move the frame in the left direction so that we can adjust our centering. All right, so we have set it at 3008. Okay. Almost there? Okay. Now that I have basically set the distance, now I'm going to be able to center, and it's going to even tell me which way I need to rotate, and then it also is telling me I need to square. Okay, so what I'm going to do is I'm going to rotate this knob here on the back side. That allows me to square the crossbar to the vehicle thrust angle. So if you notice, very precise adjustments. Okay? Now that I have squared the vehicle, now I'm going to center the crossbar. And it's telling me I have to go to my left in order to get to my measurements. Okay? Now, okay. So if you see, there's a tolerance with there's a range that is acceptable for the vehicle manufacturer to be in. And that's when the numbers are going to turn green, right? But, of course, we wanted to get it as close to the actual spec to be as accurate as possible, right? Now that we have adjusted, now we are able to lock the frame into position. Basically what we're going to do is rotate these knobs on the base of the unit to just lock the position of the frame. Now that I have my frame distance set up, and I have centered and squared the crossbar, I have placed the frame. So in the next step, I'm actually going to go into the target placement. So as you notice, we're utilizing our camera kit. But while I'm doing this, I also want you to note that Autel gives you options, okay? The first option that you have to set up the frame is a mechanical tape. Okay. So you can do this, measure the distance to the center of the front wheel, mechanically if you wanted to. Okay. Or you can utilize laser tape. So we have a board here that would allow you to basically set a specific distance via laser. Or you can optically position the frame by utilizing the cameras. Okay? So we have 3 different options for that distance of the actual frame. Now that we've placed the frame, we're going to go into the actual process of placing the target board. Okay? Do not install the target board holder before the sliding block on the holder is tight. Install the holder to the crossbar, okay, and secure it with the lanyard. So we're basically, if you notice, we have these target boards and they've got magnetic dowel pins and guide pins so that we can just place the targets on the target board holder. Move the 2 sliding blocks, okay, on the back of the target board holder and place it at a distance of 360 millimeters from the center of the crossbar. Okay, so we're going to place the right and the left target on 360 millimeters. So when we are placing targets, we're dealing with 3 things. We're dealing with the height at which that target is going to be placed. We're dealing with the distance from the center at which that target is going to be placed, and we're dealing with the leveling of that target so that it's actually completely facing the component. Okay. So now we're going to hit OK, and we're going to go to our next step. Right? Now, it's telling us the left and right target boards. If you guys notice, these target boards look alike. But if you place them in reversed order, it will fail the calibration. That is why it's very important for you to see, and it'll show us the way it should be mounted on on the actual target board holder. Next, what we're going to do is we're going to level this frame. So in order to level, we're going to rotate these knobs on the base so that we can observe our levels and so we're going to place the bubble in the center of the level. Once we have done that, we have actually leveled the frame. And lastly, last part is going to be raising the bar and the targets to a specified height. So in this case, if I were to be actually calibrating on a alignment rack, well, I have an actual holder booster, and it's going to have me raise it to this height. If not, since I'm doing it on a level 4, it's going to tell me to go to 1300 millimeters. So that's what I'm going to do. I'm going to raise the crossbar and the target board holder and the targets to 1300 millimeters. So we're going to have a ruler here on the back that indicates what that height is, and we have a little red mark that will show you when you get to that 1300 millimeter mark.
It's nice to push the button too.
It's absolutely nice to push buttons. You want to make sure that the ignition is on. Okay, and now we're going to hit the OK button. It's going to ask us to measure the wheel arch. Right? Why do you guys think there's this? This is a calculation that it's doing in order to compensate, make sure that the ride height is the correct one. Okay? So in this case, I'm going to take my I'm going to measure to 710 millimeters. That's on the right side. On the left side, 705 on the left side. Alright, so now I'm entering those values into the scan tool.
Gotcha.
And it's going to go through the calibration process. Alright, so while it's doing its thing, it's going to go through the calibration, and we've got our results here of the calibration. Okay. So factory aim, yaw, roll, and pitch. This is the actual calibration of the camera system. Okay? So if you see, very simple. Fast, accurate, simple. Okay? Can't really ask for more. We're going to snap a picture of this so that we have the record of a completed calibration. Okay? Once we do that, we're going to hit OK. And now it's going to take us back to our ADAS calibration menu, where I can do another calibration. Okay? So since we're on here, and we've got a couple of minutes left, well heck, I've got an hour, so let's just do 2 calibrations for that. Okay? Let's go into the laser radar. And we're going to do the calibration for the forward-facing radar, which, by the way, we're the only ones that are going to do this. Okay. So, again, why am I doing the calibration? Well, I've done a wheel alignment, or I've repositioned I took the radiator out and I needed to take the Acc sensor out. So I'm going to hit OK. Once I have done that, again, it's going to give me a list of tools that I'm going to need in order for me to perform this calibration. Okay? Let's hit OK. And again, environment, very important piece. I need to make sure, especially since I'm dealing with radar, metallic mass objects are going to be an important piece. Again, the other thing, the vehicle placement. How I'm going to position the vehicle is also very important. Adjust the tire pressure to the placard value. Most rental car companies, they will overinflate the tires by 5 psi. There's a lot of instances where I've seen people just not follow placard value. So just make sure that your tire pressure is at the specified value. Next, make sure that there's no empty cargo, right? Anybody that, let's just say, bought a case of water, somebody's coming from Costco or wherever, you need to make sure that there's no additional load on the vehicle. Why? Again, pitch, yaw, and roll, right? So I'm going to show you with the IA800 how easy it is to place this frame. All wheels are the same tire size, the actual manufacturer recommended size, and make sure that you are having a clean current maintainer connected to your battery, because anything that we're dealing with voltage, very important. You never want to hit the Calibrate Now button and all of a sudden now we lose communication with that component. It's like pulling a plug while installing Windows on your computer, right? You never want to do that. So, the Acc sensor is generally located on the grill, right? Most of the time when we see these type of emblems that are plastic, this is a permeable plastic. And so we have radar. Note that if you have a stain, like a bug spot, right, you will need to clean the radar surface before proceeding with the calibration. Also, you want to make sure that this is not cracked, right? If there's many instances when you're driving and there's debris from the road cracked, emblems are very common in this vehicle, and you should not attempt calibration unless this surface is clean and, complete. Okay, so no cracks, no dings. A lot of these surfaces, the face of the radar, sometimes will be bent by a rock. If needed, remove the grill or the front bumper to check the sensor if it's damaged. Make sure that it's attached firmly. Ensure the surface of the radar is clean. Okay, it varies from model to model, obviously. Okay, so now, next step, set up the frame. So once I have dealt with my environment, made sure the vehicle is properly placed, now I'm going to go to frame placement. Again, it's telling me I'm going to need to zero out the adjustments that I have so that I can proceed with moving the calibration to level ground, rotating the fine-tune bolts, and aligning all the pointers so I'm zeroing out the calibration frame, getting it ready for placement. Next page. Again, place the calibration frame directly in front of the vehicle, adjust the height of the crossbar to ensure that we're going to be able to pick up those targets on the rear wheels. So we're going to adjust the height by pressing those buttons. And next, we're going to turn on the cameras, we're going to plug in the power and turn on the cameras. Okay, next page, we're going to place the targets that we had already placed those, but this is the step where we place those targets on the rear wheels. Now we're going to place the distance target. If you notice here, it's actually telling us to place it in its front bumper, right? Okay, so basically it's going to have us where the sensor is located, being able to place that in bumper. Okay. Now it's going to acquire the readings from those targets so that it can accurately position the frame. Again, frame placement is distance, center, and squaring. We need to restart our cameras. Okay. Okay. Now again, we can see okay. Now it's telling us to remove this distance measuring target. And now it's telling us how to position the frame again. So we're going to push the frame forward till we get to 1,256 millimeters. That's the target, right? And then the centering, we're off by 22 millimeters, and we're off by 1 or 9 degrees. Perfect. Again, there's a tolerance here, right? The manufacturer has built in a certain tolerance in placing the target, but the fact that we have 6 cameras allows us to be pinpoint accurate. With this system, repeatable, accurate, easy. Those are the key words that you've got to stick with actually using this system. Perfect. Fantastic job. Thank you. All right, so basically, we are within the manufacturer's specs, and we're able to once we place the frame, we're going to go in and lock the knobs on the base so that we can actually lock the frame into its position. Once we have set the distance, centered and squared, now we have placed the target or the frame. Now we're going to go into the target placement. So we're going to hit OK. Again, it asks us to make sure that you have placed the frame correctly before going into this step. And now it's asking us to attach our target. Okay? So, as you can see, it gives us this radar, and we're able to mount it directly to the crossbar. And it says also to make sure to rotate, because we have various angles at which we can have this target placed. So it wants it to be perpendicular to the ground. So we're going to rotate that knob to position 2. Now it's going to have us basically level that target by rotating the knobs and ensuring that the bubbles and the bubble levels are centered. So level 4 is very critical when you're doing radar calibrations. And the tolerances that you're going to find with radar are much tighter than the tolerance that you would find on several cameras. So once we have centered the bubbles and the bubble levels, we're going to proceed with the actual height. Adjust the height of the crossbar, and as you can see here, I have a laser that comes out of this reflector, and we're going to place this in the center of our emblem. So adjust the height of the crossbar and move the reflector left or right to center on the emblem, which should be the center of our radar. I'm going to bring it a little bit to our left. I'm going to lower it just a bit. Yes. Perfect. Alright. So now that it's centered, it just asks us to recheck the bubbles and the bubble levels to make sure the target is still level. Now, we're going to hit OK. And this is the key point, right? When I see this message, ensure the ignition is on, I want to check my voltage one last time. Make sure that I've got enough voltage to carry out the process. So, we're checking our ignition switch. It's on. Now we're going to hit OK. Okay. Following conditions. Vehicle's not moving. Ignition is on. Calibration device is set. And now we can hit OK. So, okay, it's ready, and it gives us some preliminary readings on pitch, yaw, and roll, right? So it gives us the angle, and it tells us the results of the calibration process. So again, I can capture this image to have a result. What is the end result? And I have that for my records. Once I have completed the calibration, the next step is going to be test driving the vehicle. Okay, so I'm going to recycle the key to reboot the system. Basically, I'm going to turn off and on the system, and now I'm going to go for a test drive. Make sure that the systems are operating as intended, as designed, right? So, I'm going to hit escape. And it's going to take us back to our calibration. So see here, pass no fault, right? I want to make sure that the systems that we've calibrated have no issues. Now, obviously, we could go into the types of ADAS systems and the types of calibrations, but this class is really designed to teach you how friendly it is to use the IA800, how easy it is to set up and go through the process. For a first-time user, for somebody that is not comfortable with ADAS, this system performs beautifully. It's very, very easy to use. Okay, we're going to escape from that. Once we have test driven the vehicle, we will come back into the shop and conduct a post-scan. Again, 2 reasons. 1, documentation, right? Second is to make sure that we're delivering the vehicle, you know, this is my proof of I did the calibration and everything is good to go. You can attach up to 5 photos on our post scan. One very important photo to attach is the results of our calibration. Right? We did a camera and a radar calibration in under an hour. Okay, and that's me talking through all the steps. Right? So I can embed my calibration results for my radar and my calibration result for my camera, and I can take pictures of the vehicle. This is how I'm giving it back to you. So I have a record of how I received and how I'm delivering the vehicle back to you to close out the workload.